Good morning, Accelerated Algebra 2 students. We're going to go over a couple of key things about hybrid learning. Some of this you may have heard, so I'm going to go fairly quick, um, just about what to expect for third trimester. Okay. First thing, there will be a safety video in Schoology for you guys to watch, and this is really fourth period. Sixth period, you don't have to watch this because you would have already watched this earlier this morning. So fourth period, I'll put a link in Schoology. You're going to have to watch that quick. It'll go over these items right here. But I just want to give you a quick idea of what is Group A's schedule. So Group A people, you guys are in person Tuesday, Wednesday, and then Group A, you are in person Monday, Tuesdays, and Mondays are 4, 5, and 6. Tuesdays are 1, 2, and 3. Wednesdays and Thursdays, you'll be learning from home. Following the same schedule, then it goes Wednesdays are 4, 5, 6. Thursdays are 1, 2, 3. And then Fridays, everyone will be learning from home. That's our independent work days. You'll log into Schoology, check updates and assignments. That's usually when we're going to do our quizzes and tests. All right, Group B, yours is just flipped. If you're a Group B person, you are learning in person on Wednesday and Thursday. Wednesdays are 4, 5, 6. Thursdays are 1, 2, 3. Monday, Tuesday, you're going to be learning from home. And then we will always, when you're learning from home on the days that you're not in school, you will jump in and join our Zoom session unless you hear otherwise. Fridays are always going to be our independent work days, just so you know. That's basically like what Wednesday was last trimester. Lunches, if you are in my class for lunch, that means you would have a lunch if you are, that would be period 6 only. So if you're in period 6, we will have a lunch. You're going to go down by the library and go to the back stairwell to get to the cafeteria. And we'll talk more about that as we get closer to lunch. Just remember, transition time is not passing time. You're just going to your next classroom. Go directly there. Do not hang out in the classrooms at all. And there should be no hanging out or socializing at the rails or the hallways. Just go directly to class. Okay. Again, make sure you follow the arrows. There's correct directions to walk around the circle or going down stairwells. So follow the arrows, and that is a mandatory thing. So please make sure you are following all requirements, maintaining the 6 feet of social distancing. If you are taking the bus, in general, the location where your bus dropped you off at is the same location where your bus will pick you up at. So in the front of the school, which is the east side, if you were on the buses here, then they're going to be located. Now, I will mention they might not be in the exact same order, but it will be on the same side of the school. If you're dropped off by the auditorium, which is the south side, then you're going to look for your bus there. Just remember where you're dropped off is where you'll be picked up. Buses do not always line up in the same order, but they will always be on the same side of the building. Be prepared to board and exit the bus while maintaining 6 feet of social distance. All right, that's all we got in terms of the safety issues. Now we're going to jump right into the lesson for today. For today's warm-up, I have 3 problems. What I would like you to do is pause the video and work through each problem. Your goal is to solve for x. And just a quick reminder of PEMDAS. Remember, PEMDAS was in the order moving from left to right. We use that to simplify. But if I want to solve, if I want to get x by itself, then we have to do the reverse order. So start with add, subtract, then multiply, divide, deal with exponents and parentheses last. So go ahead and hit pause and we'll work through this in just a second. Let's solve the first one here. We're doing the backwards of PEMDAS, which means we have to deal with add or subtracting first. In this case, I need to undo the -2, so I'm going to add 2 over to the right side. And then I have to multiply or divide. Now notice, this is 4 times x squared. I have to get rid of that 4 first. That's usually one of the bigger mistakes students make. And then that gives me 13. Now, the next step is to deal with the exponent, the e. Well, how do I get rid of a square root? How do I get rid of a squared? We have to take the square root of both sides. I'm going to throw in one extra thing you might not do, but what actually happens is the square and square root reduce out, and what's left over is the absolute value of x. Now, the reason why we say the absolute value is because this answer could be positive or negative. So another way to write that is calling it plus or minus the square root of 13. All right? Because why is that true? Well, think of if I go back and check my answer. If I plugged in a positive square root of 13, I would get square root of 13 squared, which is positive 13. But what if I plugged in a negative square root of 13? If I plug in a negative square root of 13, the negative squared turns out to be a positive anyways. So both of these solutions will result in a true expression. Okay, the next one. Now notice here we have parentheses and exponents. And I can't do anything with the x minus 4 until I get rid of that squared. So I'm going to actually jump right to the exponent side, and I'm going to take the square root of both sides. Now when I do that, I actually end up with the absolute value of x minus 4 equals a plus or minus, now the square root of 81 is 9. Now this is kind of important because that means that x minus 4 is going to be equal to a positive 9, or x minus 4 is equal to a negative 9. We actually have two different problems now that we have to solve. So then when I add 4 over to this side, I end up with one of my answer being 13. If I add 4 over here, I get negative 5. So I get two different answers. But if you were to plug those in, notice 13 minus 4 is positive 9, squared is 81. Negative 5 minus 4 is negative 9, but when I square it, it turns out to be positive 81 as well. So both of these end up working. And also notice how I am talking about checking my answers. That's always a really good thing for us to look at. All right, the last one is I've got a lot going on here. I actually have kind of almost all of PEMDAS working, but I have to deal with the add subtract first. So I have to move this 5 over to the other side. And you don't have to show that work. But if I subtract 5, I get 72. And then the next thing we're going to do is we have to multiply or divide. In this case, it's 2 times, so I have to undo the multiplication by dividing by 2. And then I get 36. Now I want to point out one quick thing here. Notice how this structure is the exact same thing as this structure. I have a binomial squared equals a number. Well, same thing here. So I'm basically going to follow the same steps I did in number 2 now. I have to get rid of the square. So I'm going to square root both sides. And that gives me the absolute value of x minus 1 equals 6. Now the reason why I could put plus minus here, but I don't technically need it because the absolute value ensures that it's going to be a plus minus. I didn't have to put the plus minus here. But what this tells me to do is now I'm going to get two answers, right? I'm going to get one where x minus 1 equals positive 6, or I'm going to get one where x minus 1 equals negative 6. So that's why that plus minus is kind of important. We're setting up two different equations, and then we're solving. Now it's quick algebra. Solve for what's left over. X equals 7 is an answer, and x equals negative 5. Okay. Now again, you should be able to plug both of those in and see that they result in the same answer, and the left side should equal 75. So I encourage you to pause the video and check your work. All right, one little hint here is notice what we just did. And this is going to be something that's kind of important for us today. Notice how each quadratic expression, why did I call it a quadratic? Because every single one of these had a square value in it. Notice how there's only a single x here. There isn't another term with an x in it. And when that happens, you can use algebra to just solve your process, right? So anytime you have just a single x, Just use algebra, use the backwards of PEMDAS, and you can work through it. You don't need any algebra tricks to solve. All right, quote for today. Don't let failure be an ending, make it a beginning. We actually already went through the trimester 3 welcome back videos. So welcome to Accelerated Algebra 2 with Trigonometry. I just want to point out that Miss Hires also teaches this class. She's in room 007, which is right below us, actually almost directly below us. And then there's myself. Both of our emails are the same. If you are visiting us, remember that my room is in the English circle, and then Miss Hires is in the math circle if you ever need to see her. What do you need for this trimester? You need a math-specific notebook. You need graph paper, and remember we have graph paper available in the Media Center. You should have picked that up when you picked up your textbook. If you did not bring your textbook, if you did not pick up your Algebra 2 textbook, you'll need to do that today. If you're in Tartan, go to the Media Center, bring your textbook, bring your geometry textbook, and get that checked back in, so then you can check out the Algebra 2 textbook. And then you have a graphing calculator on your laptop. Every school laptop has the TI-84 simulator, and I'll make reference to that as we use it. We won't need it today, but you may have your own graphing calculator at home, which you can also use. All right, so what are we doing today? We're going to learn the difference between two different expressions. Now, if you look at this, both of these are almost the same, right? And by the way, if you want to, you can write this down. I think the next slide, the next slide has the title of the notes. This is just getting us set up. If you don't want to write this, it's fine. You don't have to. But I want you to notice there's a difference between the way these two are set up. This one is an expression, and this one is an equation. If there's an equal sign, that means we can solve, and we need answers, right? That means we're going to get x equals, and sometimes there's more than one answer. Maybe there's two answers. But if we have no equal sign, the best we can do is simplify. And the question then is what's the difference, or how do we simplify? Well, we're going to factor when possible. And I'm going to show you this, but we'll actually teach it to you a little more on the next slide. So there's multiple ways to factor this. The way that you probably have taught, if you've gone through Tartan, the way that you've learned before is the box method. If you haven't, I'm going to encourage you to really pay attention, and I will teach this method in more detail as we get along with the notes today. But what do? We take the trinomial and we just write it in the diagonal. And then we're going to take the corners of each diagonal here and we're going to multiply them. It's kind of like multiplying the first and last term, right? So positive 10 times x squared is 10x squared. So that's the key part, is we multiply the first and last term. And then we're looking for what are the factors of this expression, 10x squared, that add up to give me the middle term. Well, what times what gives me 10? 2 and 5. However, those don't add together to give me a negative, so I need to make both of them negative, and a negative 2 times a negative 5 still multiplies together to give me a positive, but those are my two factors. Okay? I'll provide more detailed notes with other examples, but now that our box is filled in, we're going to look at just the pairs. What do the top two pairs have in common? They have an x. What do the bottom two pairs have in common? Well, they're both divisible by 2. And I'm going to leave the negative off right now. Maybe we forgot the negative, and I'll show you why I'm going to check the signs later. So this isn't technically right, but I've got, what about the top, or the left pairs, right? X squared and 2x, they each have an x in common. And then what about negative 5x and 10? Well, what if you said, oh, those just have a 5 in common? Now, why is the box method really friendly? Because we can check. Does x times x give me x squared? Yeah, these two are right. Does x times 5 give me negative 5x? No, it doesn't. It gives me a positive 5x, which means this x is already positive because it makes the first term right, so this would have to be a negative 5. And then x times negative 5 is negative 5x. And what about x times 2? Same issue, right? A negative 2, the only way I'm going to get the negative is if that's a negative 2 times x. And then that should automatically make the last box equal. Does negative 2 times negative 5 give me positive 10? It does. So what is my answer? It's the top expression times the bottom. And do keep in mind, you have to write this out, right? You can't just stop at this box because this isn't officially in factored form. Factored form is if I was to FOIL this out, do I get back to where I started? So what makes this problem different than the one that has an equal sign? Well, factoring can only get us to the spot where it's simplified. But solving means to factor and then solve. So I'm not going to do all this work because it's the same problem. But what I'm going to do is I'm going to take my answer. Remember, x minus 5 times x minus 2 is just another way to write this expression. And then that's equal to 0. Well, if two things multiply together to equal 0, that means one of them, or maybe both of them, are equal to 0. So we're going to take each individual factor and set it equal to its own 0. That's actually called the zero product property. And then we're going to use algebra to solve. If I move the 5 over and I move the 2 over, I get my two solutions. So notice I get two solutions for this expression. So, by the way, notice we couldn't just use regular algebra to solve because I have an x squared and an x, and I cannot just isolate the x individually if I've got three terms and they're all different types. All right, so what are we doing? Our goal today is to learn how to factor and solve. Now, sometimes we don't have to factor and we can jump right to solve, but this section, notice we're covering 3 sections here. A lot of the things we're going to do, we have to factor first. So my goal is to teach you guys how to factor. Okay? What I would do is pause this one right now, make sure you get all the notes, and then we're going to start right away into this. And I'm going to use this example to kind of lay out some more detailed instructions on what we do when we solve. All right. Well, notice we've got a lot of z's going on. We got a lot of different terms. So what I have to do is I have to move everything over to one side. And my goal, we're not going to talk about this a lot right now, but you've probably seen this in Algebra 1. Since it's a squared term, it's a quadratic. And when I want quadratics, I want it equal to 0, which means I have to move everything over to one side. And my goal is to always make the a value positive if possible. So what I do is I take the 2z and I'm going to move it over with subtraction. So then what's left over is 6z squared. And then I have my z's combining here to give me negative 3z. But then at the same time, I've got a 15 that's going to move over. So I'm going to subtract that as well. And that'll give me negative 30 equals 0. Now notice, the right side reduce out. And what's left over now is a trinomial that we can try to factor, but there's a trick that might make our life a little easier here. Notice how each one of these are divisible by 3. If I divide everything by 3, then that's going to make this problem a lot easier to deal with. It's still not going to be super friendly, but anytime I can reduce out a factor, that just makes it easier to work with. All right, so we divided by a factor of 3 just to make these the numbers smaller. And what we're going to do now is we're going to factor. So I kind of think of this as side work. And this is where we want to take the box. And you'll notice this one's a little bit more unique than the first one because we've got an a value that's greater than 1. So I've got a 2 there. Well, we're going to treat this same way we did with the other one. So we take our trinomial and we just write it diagonally in the box going from left to right. The first step is you're going to multiply the two corners. So negative 10 times 2z squared is negative 20z squared. And then I want to find, okay, if I multiply those two together, I have to look for the factors that add to give me negative 1z. And some students like to do this if they want, just to show. So that's how I got the negative 20z, was we multiplied. And then we're looking for factors that add to the middle term. Well, that middle term is right here in the center of our circle. That's why it's circled, is that's the only thing we use that negative z for. So what are the factors of negative 20 that add up to give me a negative 1? Well, two numbers that multiply together to give me 20 that are 1 unit apart are 5 and 4. And then how would I get the z squared? I would have a z at the end of each one of those. But now the question is that when these are added together, they have to add up to give me negative 1, which means the larger value has to be negative. Negative 5 plus 4 is negative 1. So once we identify the factors, those two values are going to go into the remaining open boxes. All right. So the next thing then is we're going to actually look at the pairs. By the way, once we fill in these two boxes, we don't use the center part anymore. If I want, I could even cross that off. So let's look across the top. 2z squared and 4z. Well, a common factor they both share is 2z. Negative 5 and negative 10, a common factor is a negative 5. Then we're going to go up and down. 2z squared, negative 5z. The only thing they have in common is a z. And then 4z and negative 10. Well, the only thing that goes equally into each one of these is a 2. Now here's where I like to check my signs and make sure everything works. Does z times 2z give me 2z squared? Yeah, this box works. 2z times 2 is 4z, and so this works. Z times negative 5 is negative 5z. If these three boxes work and all of these are correct, the last one has to work. Negative 5 times 2 is negative 10. So those are my factors. And it doesn't matter the order that you write them. I could put z plus 2 first. Notice this is a positive 2, so I could put a plus there. And then I've got 2z times minus 5. 2z minus 5. And those are my factors. So we took this trinomial, rewrote it as a factor, and now we're going to set it equal to 0. We're going to set each one of those parentheses equal to its own 0 so we can solve. So subtract 2. In this case, I would add 5. So I'm going to add 5, and then the next step would be to divide by 2. So why not do that all in one step? So z equals 5 halves. Now, those are my two answers. If you want, you could plug in negative 2 everywhere you see a z in the original expression, and the left side should equal the right side. Same thing here. If I plug in 5 halves, that should work as well. Okay. Now notice, there was an equal sign. Since there's an equal sign, that means I got two answers. I solved. You're not always guaranteed two answers. Sometimes you get one answer, but it's the same. That's called a multiplicity, and we'll talk about that as we get into the graphing side. Let's look at this example. Now notice, I have different terms, right? B squared plus 17, B equals 18. Well, what we want to do is we want to move the 18 over to this side. And when you're factoring, your goal is to always make the value that has the squared positive. So see how this is a positive 1 here? You want to make that, you want to keep that positive. If it was a negative, then I could move these items over to the other side and we could make it that way. So this might be one that you actually could do in your head. What are factors of negative 18 that add up to give me 17? Now you might be able to do that, but right now, you're probably not there yet. So we're going to go ahead and draw the factor box. And we're going to put each piece into the diagonal. Then we multiply the corners. Multiply negative 18 times b squared. And then I'm thinking, what are the factors of negative 18 that add up to give me 17? And one of the things students often forget is, remember, 1 times 18 is going to give me 18. But if I make the 1 negative, negative 1 plus 18 is a negative 18 when you multiply them together. But when you add them together, you get a positive 17. So those are my factors. And they're going to go into the boxes. I get a positive 18b and a negative 1b. Now we'll do the same thing we did before. Look at the top two. What do they have in common? There's a b. What do the bottom have in common? A negative 1. Now I should say, if it doesn't look like they have anything in common, you can always factor out a 1. I go up and down, we get positive b, and then we get positive 18. You should always check, does b times b give me b squared? Yep. Does b times 18 give me 18b? b times negative 1 gives me negative 1b, and negative 1 times 18 is negative 18. So all of this works, which means I can rewrite it as a factor. And now we're back at the same step we had over here. Once it's factored, you're going to use your zero product property and set each expression equal to 0. So I'm going to add 1, then I'm going to subtract 18, and those are my two answers. And again, you can plug those back in just to double check that they work. Okay, I'm going to pause, and I want you to work through this and see if you can factor out. Actually, I'll give you one hint here that could make your life easier. So notice this just says factor. There is no equal sign, so we're not going to solve. We're just going to basically get to this point right here and then stop. But here's a hint. Look at these numbers. What is the largest number that goes into each one of those? That'll make this nice and friendly. And I know 8 doesn't go into 28. So the next thing I would check is, what about 4? Does 4 go into 28? Yeah, 4 times 7 is 28. Does 4 go into 120? Yeah, 30 times. So what you can do to make your life a little easier is pull the 4 out first. Okay? So what that means is that 4 is actually part of our answer, but what we want to do then is just take this inner part and we want to factor that. So I'm going to pause it and I'm going to let you guys work through. I want you to factor this piece and then just know when you get done with your final answer, you get your two factors, you're going to have that 4 just sitting on the outside. Because it didn't go away because there's nothing on the other side. There's no equal sign to get rid of a factor of 4. We just have to account for it. All right, work through it and I'll reveal the answer in a second. Okay, let me show you how far I got. So I multiplied 2 times negative 30 and I got negative 60. And then I thought, well, what are the factors of negative 60 that add up to give me 7? And nothing popped up in my head right away, so I just started with 1. 1 times 60, nope, 2 times 30, 3 times 20, 4 times 15. None of these two were 7 units apart until I got to 5. 5 times 12 is 60, and they're 7 units apart. But I want the larger value to be positive, so I'm going to call 12 positive, and negative 5, the negative will be 5. So those are the factors that add up to give me negative 7. Now we're going to factor just like we did before. Going right across, we got a 2m in common. Across the bottom, we got a negative 5. Across going up and down, we have a factor of m. And then here we've got a factor of 6. Now you should double check. Does 2m and m give me 2m squared? 2m and 6 gives me 12m. m times negative 5 is negative 5m, and negative 5 and negative positive 6 give me negative 30. So that works out, and those are my factored pieces. And again, it doesn't matter which factor you write first, right? I could put the 2m minus 5 here and the m plus 6 here, but there was no equal sign, so as far as I went, we just simplified, and this is in factored form. Now, if I told you to solve it, you would put an equal sign here, and then you would set each parenthesis equal to 0. This 4 would actually divide out. The multiplier doesn't really do much to the answer. All right, here are some trickier ones that I'm going to kind of have you go through. I'll do the first one, and then I'm going to have you do the second two. But you'll notice something with this first one, 2 and 7. Now notice, the directions say factor first and then solve. So I didn't put the equal sign yet because I want to focus on the factoring. But what I'm going to have you do is pull out a factor of 2 first. So I'm going to divide each by 2. That 2 doesn't go away. It's still there. But now we have to factor the middle, what's left over. Now notice, I have an x squared, but in this case, I don't have the extra term, the x term that's usually there. So what I have to do is I have to think of that as being a 0x. Now, once you become really good at this, you'll know the answer and you won't need to show any of this work. But we're going to go really quick. And my goal is to factor the middle piece. We're not worried about the 2. We know the 2 is going to be part of my answer. I want to factor this. And my goal is to think of, well, what are the values when I multiply this corner times this corner? Or you can think of it as the first and the last term. When those are multiplied together, what times what gives me negative 36x squared, but adds up to give me 0? Well, the only thing that can ever add up to give you 0 is when you have a positive and a negative number that are the same thing. So what two numbers multiply together to give me 36? A positive 6 and a negative 36, a negative 6. When I add those two together, they give me the 0x. This is called a perfect square. Remember, 36 is a perfect square. There is a pattern here. I'm not going to focus on the patterns, but if you recognize it, then you kind of know there's a quick shortcut here that you can see. So I have my right factors. When I factor across the top, I get a 6. Oh, excuse me, on the bottom is a 6. The top was an x. Going up and down, I get an x. And going up and down, I get a negative 6. And again, you should check all these to make sure it all works. And then we get a positive x plus 6 and x minus 6. And then don't forget that 2 that we originally pulled out. Now, there's the factor piece. Right? So we factored, but now they want us to solve. So once it's factored, set it equal to 0 and solve. Now here's the hint. Remember that 2 that we pulled out? That 2 technically is just a multiplier. So since it's equal to 0 now, I'm going to divide that 2 to the left, to the right side, and it goes away. Which means now I'm going to use the zero product property and set each one of these parentheses equal to its own 0, and then we'll solve. We get two answers. One is positive 6, one is negative 6. Now, if we didn't have you factor, and I just said solve, you would do this just like we did the warm-up, right? You would set it equal to 0, move 72 over, divide by 2, and you get x squared equals 36. And then you take the square root, and you get this answer. So I do want you to know that we factored this one, but this part, because there's just a single x, you could use regular algebra if all you wanted to do is solve. Okay, now there's a pattern. If you see the pattern in this, that makes this problem much easier. If you don't see it, it makes it more challenging. I'm going to hint at the pattern here just to see if you get it. The first thing I'm going to notice is that that middle term is missing. I'm going to call it a 0. Now, let's think of this, just kind of patterns. And it doesn't always work. I'll hint, once we get done with this, I'll tell you why it works. But how do you think we got the 81x times x? Well, there's a strong chance that 81 came from 9x times 9x, right? And then how do you think we got the negative 25? Well, 5 times 5, but 1 is positive and 1 is negative. And that's equal to 0 if we set it up. I could have, and maybe I should have, done it this way. You could still try this the traditional way. 81x minus 25, and then put the 0x right here. Now, here's the part that you could try to multiply 81 times negative 25, and you would get a pretty large number there. Let's see. You would get negative 2025x squared, and you'd have to look for the factors of that. So what times what multiply together to give me that large number? Now, it doesn't really work perfectly, so the way that I would do it is I would see, well, wait a minute. How did I get the first two? There's a chance that this could have been 81, right? 9 times 9 is 81. And then how would I get this part? Negative 5 and positive 5. Now, what that would be is what numbers would go here? Well, 9 times 5, that would have to be a 45x, and 9x times negative 5 is negative 45x. So let's just check. Those two definitely add up to 0, but what is 45 times negative 45? When I multiply it together, notice how I do get that answer. So this only works because the first term and the last term are perfect squares, and it's subtraction. If this was addition, it would not work out this way. All right, so then that's the factored form right there. It is completely factored. The solving part is when we set each one of those equal to its own 0. So take each factor, set it equal to its own 0, and here I'm going to subtract 5. So I get a minus 5, and then instead of putting a 9 here, it's going to divide over. So let's call that negative 5/9. And then here I would add 5, so I get x equals 5. And there would be a 9 here, but let's divide that over. Okay. Now, we kind of run into the same problem with this one. We've got some pretty big numbers, and there's a huge hint. It's not always going to be this case, but notice 49 and 64. Well, how did I get those numbers? What could have given me 49? 7 and 7. What could have gave me 64? 8 times 8. So let's try something here and just see if everything works out the way we want it. Okay, so instead of multiplying the corners like we did before, we get 49 times 64, which is a big number. That would be a positive 3,136, right? I don't want to look at all those factors. So what I'm going to do is I'm going to try something. I'm going to say, well, you know what? I think this was from 7x and 7x. And then I think 64 came from a positive 8 and a positive 8. Now, I can't just say, yes, that's my answer, right? Because I should try to determine what has to go in these two values. Well, 7 times 8 is 56x, and 7 times 8 is 56x. So let's check. Does 56 times 56 give me what I originally thought I should. And if you multiply 56 times 56, that is correct, which means because these two values were perfect squares, it made this a little friendlier for us to solve. And there's my factored form. And then notice, if I set it equal to 0, then I would set each one of these factors equal to its own 0. But you'll notice they're the same, right? So, you know what? I'm going to throw in one extra step here. Maybe I'll do that later. So what if I solve one of them? Subtract 8, divide by 7, I get 8/7. Well, I get the same answer here, right? Negative 8/7. So that's called multiplicity, or when you have the same answer appear twice. There is one extra thing that I should point out. If you have the same factor multiplied together, you could write that as a squared. And that actually is similar to one of the warm-ups we did today. So it could be written this way. Notice if I solve it, I get the same answer, negative 8/7. All right, this will be our last problem for today. Find the dimensions of the rectangle if we tell you the area is 30 square feet. Well, this kind of ties into geometry. What do we know? We know the area is 30 square feet. And I know the length and the width. Right? They give us expressions for both of these. So 3x plus 1 times x is how I would set up this equation. And then I'm going to distribute the x. I get 3x squared plus 1x. And now notice, this is a quadratic. There's a squared, but it's equal to 30. I want to make it equal to 0. So I'm going to move the 30 over to the other side with subtraction. We're going to subtract 30. Now we're going to try to factor it. So notice I can't factor out a common 3 because this is a 1. So there aren't any common factors to make this problem easier. But I can then set up the same structure we just did. And remember, what do? We take the first term and the last term. Those are the ones in the corners. We multiply them out. So I'll get negative 90x squared. And I want to think, what are the factors of negative 90 that add up to give me 1? Well, I know 9 times 10 is 1 unit apart. So 9x and 10x, but which one is going to be negative? When I add them together, I need to have more positives. So that means 10 will be the positive one and 9 will be the negative one. So 9x and negative 10x. And then we're going to just play that same factor game. What do the top two have in common? They only have in common an x. What do the bottom have in common? Interesting. I know they have a 3 in common for sure. Now, maybe there's a sign here. I'm not sure. I'm going to leave that a 3 for now. But I know it's not right. So then I'm going to check the top up and down here. 3x squared and negative 9x, those have a 3x in common. And negative 10x and negative 30, well, wait a minute, those have a, this should be a positive 10. Sorry, I wrote it here, this should be a positive 10. So positive 10x and negative 30, I know 10 goes into each one of those evenly, and I'm pretty sure it's going to be positive. But I know I did something wrong because 3 times 10 is not negative 30. So I'm just going to check everything. X times 3 is 3x squared. X times 10 is 10x. 3x times 3 is not negative 9x, which means that one should have been negative. Now that works out, which means the last box, negative 3 times 10, works out. So if I set this up, I'll take my factors, set them each equal to their own 0. And we're going to solve. So I'll move the 3 over. I get x equals 3. Then I'll move the 10 over and then divide by 3. Now notice, we can't just stop here and say, oh, these are both my answers. Because think about this. X is your width, right? Can you have a width that's a negative 10 over 3? No, we can't have negative length. So this is something that does not fit the context of the problem. Even though it was a solution, it doesn't make sense in the real piece. So that means the only answer that works is x equals 3, and then we have to find the dimensions. So that means the width is 3 feet. And what is the length? Well, plug 3 in for x. 3 times 3 is 9 plus 1. And my dimensions are, it's a 3 by 10 rectangle. And notice, 10 times 3 is 30, so it meets the area of everything. Okay, really quick, I want to show you how to sign up for your new Delta Math. So what you're going to do is you're going to log into Delta Math like you've always done. So you'll go to Delta Math, and then you're going to go to Tools. Once you log in, go to Tools, and you need to Manage, Login, and Course. So once you do that, you'll get brought to your login stuff. There's your name, your login. You need to edit what class you're in. So you're going to click on Edit, and then you're going to go to the drop down, and you'll notice some of these are renamed, right? We've got 4th hour accelerated algebra 2 with trig. And so if you're in 4th hour, you want to select that one. If you're in my 6th hour, make sure you do the one that says 3rd trimester. So 6th hour accelerated algebra 2 with trig. You're either going to be in my 4th or my 6th. Click on it. Make sure you unclick the other one that you're in. That'll just that way you won't see the stuff from last trimester. Okay, so you should only have one of these clicked, and then you're going to hit save. When you do that, click OK, and then go to Delta Math, and you should see the assignment. It's not available yet, but it will be available on the day you sign up. All right, so again, what do? We went Tools, Manage, Login, and Courses, and then go down to the Edit on the bottom for Teacher Class. If you are new to my class for some reason, you need to access my teacher code. Here is my teacher code, 416534. All right, so if you need that, that's my teacher code for Delta Math. So when you log in, you should see tonight's homework. Factoring and solving quadratics. It's going to cover everything we talked about. There's a video up here for how to use the box method in case you forgot. It's an optional video. You can watch it if you need. If this lesson didn't give you everything you need, you can watch that and then do the select problems. That's all I have. I will be back in class next week for sure, possibly even Wednesday and Thursday this week. It all depends on when my daughter is born and how much help my wife needs. Have a great day. Welcome back to 3rd trimester, and remember to start this trimester strong. Adios.